Hello friends, today we will study something which is very interesting known as recursion. What do you mean by the term recursion? How and why do we implement recursion in any algorithm or any programming technique? And what is the output of it? What are the advantages of it? So to start with, what is a recursion? Recursion is more than just a programming technique that you will observe as we will proceed further. It is a way of describing, defining and specifying things. Now here the things are nothing but our functions, our modules or our various programming terminologies and techniques as a way of designing solutions to problem. This is also one of a very simplest definition of recursion, that it divides and conquer a problem. That is, any problem which is given to you, whether from the mathematical world or from the real world, I can divide or break down that problem and then find a solution. Then it is satisfied the need of recursion. Recursion is also defined as a function calling itself. That is, when a function calls itself again and again, it is known as recursion. How recursion works? That is one main and one big thing that we need to study. To truly understand how recursion works, we first need to explore how a function call works. Now to see how a function call works, we have to first see that when a program calls a subroutine or a function, the current function must suspend its processing. Now what do we mean by this step? That is, if I am at a particular location or if I am on a particular call, let's take a very simple example. If a person is talking on the phone and he gets another call, then we suspend the present call for some time or put it on hold and take another call. We speak to that particular person and then we come back to our original call. But what happens in this process? We don't lose the previous call. We have a link which is provided. So that is what is the main terminology or main process that a recursion follows. The called function then takes over the control of the program. That is what we just explained, that the current call which comes into picture takes charge of your program. Now let's take a very simple example to add the two numbers. So what we do, first we write a simple, because it is a C program example, we write the header file, simple main function. We declare the variables integer, n1, n2 and sum. Enter the two numbers using the printf statement. We say scanf, enter the values, that is ampersand n1 and ampersand n2. Let's see that we enter 10 and 20. So 10 and 20 are the two values that we have inputted. The third step or the next step that we write, we say sum is equal to n1 plus n2. We are adding the two values and the sum is, we print it out to be 30. So this is a small program without using functions. Now what happens when this program is converted using a function? So what do we do? Same thing, the header file, but here is the change. What we do is, we have declared a function which is known as a function prototype. Now any function that I need to call, I have to give it a name. Here I have given it a name, add num. Always make sure the names that you give to a function have some significance related to your program. I can give it any name, but just to make it significant, and to use it by the programmer or any other person, it should have a meaning related to it. So we give a function prototype. Here we are adding two numbers, so we've given it as int add num, and the two variables are int a and int b. The next step is void main. Now I start, it's a normal declaration, integer n1, n2 and sum. I enter the two values, that is n1 gets a value of 10 and n2 gets a value of 20. Now this is a regular program. Now comes the next step. Here I call my function. If you see, we have written sum is equal to add num n1 n2. This particular statement signifies a function call. What happens when this statement is written? You will see that it goes to a location where that particular function definition is there. So int add num, int a, int b. Now here whatever variable I declare inside the brackets have to be same as whatever I have declared in the function prototype. I start with this program or I start with this function code. I declare another variable known as answer. I say answer is equal to a plus b. We see that n1 value will be transferred to a, n2 value will be transferred to b. And now when I say answer is equal to a plus b, answer is equal to 10 plus 20 is equal to 30. So answer gets a value of 30. I say return answer. Now what does this return answer specifies? Return answer means whatever I have calculated in this function, from this function it will be returned to the calling point from where this particular function was called, that is at a location where my function call was written. That statement was sum is equal to add num n1 comma n2. So this answer will go and get reflected in the variable known as sum. So when I printf sum is equal to %d sum, my output will be 30. When I print, the output will be 30. So this is how I have broken down my simple add two numbers program using functions. Now we will see how recursion works. Now to see how recursion works, when a function is called, the very important feature to remember is when a function is called, the information at that point is need to be saved in order to return the calling module back to its original state. That is, from the state the function call was given. So we need to store that particular address location of the statement. And we need to save the information such as the local variables and the spot of code to return when we have finished with the function execution. So this complete scenario explains how my function works, how my function call works, and how my recursion will save the calling point and the return point value. Now when we are implementing recursion, there are few data structures which are used. Now what are data structures? These are programming strategies which are defined to design and analyze your algorithms. Now recursion works the best when the algorithms and data structures support recursion. There are two major data structures which support recursion. Those are stacks and trees. And one such algorithm which is used and implemented using recursion is a binary search algorithm. Now this binary search algorithm will be implementing in the next few sessions when we study the depth algorithms and implementation of binary search algorithm. Now what happens here is we'll be seeing simple examples of how recursion is better than the iterative methods. Now what is an iterative definition? This is an iterative definition for a simple example of a factorial of a number. Now what happens is, in an iteration, the definition and the algorithm only contains parameters and it has only flow. There is no implementation strategy which goes into picture, and it is very easier to implement than using recursion. But recursion becomes important when I have larger problems and I can divide and implement and make it simpler. Now in an iterative algorithm, for a factorial of a number, let us consider, here I have written a small function to find a factorial of a number. It is given a name factorial n, I is equal to 1, fact is equal to 1, while I is less than n. Now n is any number whose factorial I need to find. Let's take an example. If I take the value of n as 5, I is 1 and I is less than equal to 5. Fact is equal to fact into I. Now the value of fact we have initialized to 1. You will observe over here that I cannot initialize the value of fact to 0, because if I initialize the value of fact to 0, then anything multiplied by 0 will result me in a 0 answer. So you remember that in the factorial program, the value of fact has to be initialized to 1. I say fact is equal to fact into I. The value of fact is 1, the value of I is also 1. So 1 into 1, resultant is again, the result is again 1, which is stored back in the variable fact. The next statement I say I is equal to I plus 1. The value of I is now incremented to 2. The while loop gets closed, it goes back again and checks. The value of I is now 2, but 2 is still less than equal to 5. So it goes back into the loop, and fact is equal to, value of fact is 1, value of I is 2. So 1 into 2 gives me 2. It is stored back into factorial. This loop executes till my I becomes equal to 5. In the next step, when I becomes greater than 5, it terminates the loop and returns the value of fact to a place where the function factorial was called. Now the iterative solution is simple. While loop executes through all the integers between 1 to n and multiply them together. Now what happens here is the value of n, we have 5, so this loop will execute till my value of I becomes greater than 5, and it will give me the value of 5 factorial, which is 120. Now what is a feature breakdown in this? This solution is known or is called as the base case. Every recursion algorithm must have a base case to simplify to. That is, I can break it down to a simpler solution which will be the minimal and the best solution. Otherwise, the algorithm will run forever. That is, it will never come out of the loop and it will become an infinite loop. So there has to be a base case at which my algorithm will stop and terminate. Now what is a basic recursion? Now base cases always have at least one case that is solved without recursion. That is, when I reach to that stage, my program should come out at a later stage when I reduce it. Make process state, any recursive call must make process towards the base case. That is, the first instance is the checking condition, and later on when I divide and conquer a particular program, then it should always approach to my base case. Now we will see that when we have a base case and a making progress case, how do we implement a factorial of a number using it? What happens in a factorial of a number? The logic behind the factorial is n factorial is equal to n into n minus 1 factorial. What happens in this case is, if n is 5, so 5 factorial is equal to 5 into 5 minus 1 factorial, which will be 5 into 4 into 3 into 2 into 1, which will be equivalent to 20. So that is a simple example of a factorial of a number. Now, when I have the simple program written in a recursive manner, now what happens to it? I have a function named factorial. I have a variable int n which gets the value from the function call, as this is my function definition. Now the first base case in this example is, if my n is less than or equal to 1, I return the value 1. Else I go to another part, that is, if my value of n is negative, there will not be any factorial. But if my value is 0 or 1, my factorial is 1. So if it is more than that, then I come to the else part of it, and my else part will return n into factorial n minus 1. What happens over here is, my value of n is 5. So the first time it takes the value 5, it says factorial n minus 1. Here is a function calling itself. So function factorial calls itself. So first instance of 5, factorial n minus 1. So factorial 5 minus 1 is 4. It goes back to the calling function and comes down and checks if 5 is less than equal to 1. No, it is not. Comes down to the else part, and this recursive factor continues till the value of n becomes 1. The factorial of a number is given by factorial n. In the bracket, it can be defined as 1 if n is equal to 0, and n into factorial n minus 1 if n is greater than 0. So this is how my iterative process of recursion will continue. Now, n factorial, n into fact n minus 1, example 5 into 5 minus 1 factorial, 4 factorial, as 5 minus 1 is 4, the function calls itself. So 4 factorial is equal to 5 into 4 minus 1, which is 5 into 4 into 3 factorial as function calls itself. So 3 factorial is equal to 5 into 4 into 3 minus 1 factorial, which is 2 factorial. So 2 factorial is equal to 5 into 4 into 3 into 2 minus 1 is 1 factorial. So 5 into 4 into 3 into 2 into 1 minus 1, which is 0 factorial. So when it becomes less than that, it comes out of the loop. Now the recursive algorithm for factorial n, if n is equal to 0, it returns 1, else return n into factorial n minus 1, and it ends. So recursion eliminates the loop. This is what we've seen, and rewritten and implemented the algorithm using a simple if loop. So here we observe that when a simple factorial program is written using recursion, then my while loop is eliminated. The time taken for me to execute a while loop is totally removed. That program is converted into simple 2-line if-else loop structure, and it returns a correct measure. So recursion always provides a correct measure if we are able to break that particular program into base and a make progress step. Recursion is always used if we do a divide and conquer technique so that my large programs can be broken down into small steps and they reduce from a larger bit or a larger problem and shrink towards the base case when I get a finite solution. And when I reach that base case, then we terminate the recursive function. Now we will see how recursion and iteration are differentiated or compared. We see that recursion eliminates the looping atmosphere of iteration. In iteration, we have different looping structures which come into picture, and recursion uses a simple if structure and eliminates all the loops. So, how recursion and iteration can be compared? Recursion is based upon calling the same function again and again. That is a function calling itself. That is known as, in simple definition, recursion. Iteration is a looping structure where the execution jumps back to the beginning of the loop. And there are a set of statements that get executed in between this looping jump structure where it goes from an initial condition to its final condition. A function call is often more expensive than a jump. So we find out over here that there are few things which are good in recursion and there are few things which are disadvantageous or give us a little backstage to use a recursion. As a looping structure always has a less execution time, but the complexity is more, and function call is often more expensive in terms of space, as I have to always keep storing the location from where it will be moved or from where the function call is given. So what happens? We have to now see what are the benefits of using a recursion. Invariably, recursive functions are more clearer, simpler, shorter, and are easier to understand than their non-recursive counterparts. Now, when I say a non-recursive counterparts, that is the looping strategy or the iterative strategy. The program directly reflects the algorithm which is termed as an abstract solution strategy. That is, algorithm is clearly defined when we are using a recursion. The only thing that we do is, in iteration we write a complete code. In recursion, using functions, we divide the same function, we divide the same program into functions which give us more efficient outputs. And when a function calls by itself, that is, I break my program into more smaller bits, then it becomes more easy and simplified and gives me a perfect output. But with this advantages or benefits, recursion also has few limitations. What are these limitations? Recursion is powerful problem solving technique that produces a clean solution to the most complex problem, but it also describes an iterative solution. The only limitation it has is sometimes it becomes difficult for the programmer or a developer to understand or how to break a particular problem into smaller bits. When you cannot decide to break a problem into a smaller bits, then it is always advisable not to use recursion. So we can use our simpler iterative methods. Recursive algorithm usually runs slower than their iterative counterparts. And every time we make a call to a function, we must use some memory resources to make the use of the stack frame. Now why do we need a stack frame over here? We need a stack frame because we have to store the address location and the calling point of that particular function. If we do not store the calling point of the function, then we lose the track of where we have to return after we have jumped to that particular location. Now what is the purpose of recursion? As we've seen the need, the advantages, the disadvantages of recursion. Recursion is truly valuable when a problem has no simple iterative solution, or the problem becomes too large with an iterations. Then what we do is we define a base class for the function, we define a base class for the recursion, and then we try to find a solution that a recursion can be more advantageous to use than a iteration, as we reduce the number of loops in recursion and implement it with a simple if structure. There is no reason to use recursion when its use does not gain anything. Now gain in terms of space or time. If it takes more time to solve a simple problem using recursion, then it is always advisable to use iterations rather than recursion. But if iteration becomes more complicated, then it is advisable in the case to solve using recursion. We have seen the example of factorial. It can be solved using iteration, but it became more simpler when we solved it using recursion. So recursion, while implementing, has to be chosen very carefully so that it does not make a problem statement difficult, but it should be used to simplify the programming structure. Now what is the importance of recursion? A recursive solution solves a problem by solving a smaller instance at the same time. That is, I have smaller bits which needs to be solved. It solves this new problem by solving even the smaller instance of the same problem. That is, when I divide this bit, as we've seen the 5 factorial problem, as we were reducing the bits, that is from 5 factorial, 4 factorial, 3 factorial, 2 factorial, 1 factorial. At every smaller instance, the recursion was working perfectly and it was reducing, and every instance was getting smaller. Eventually, the new problem that was small and solution was becoming very obvious as we were reducing itself towards the base case. So recursion becomes very important factor when we are very clear about the base case. This solution will lead to a solution of original problem. That is, when I started with 5 factorial and reduced down to 1 factorial, by that time we reached 1 minus 1 function calling itself, we had already approached to the problem solution. So recursion was easy to implement for the factorial than the iteration. Thank you.